Greetings and welcome to the lecture series, Equations and Inequalities in Two Variables. 3.3, Finding the Equation of a Line. When trying to find the equation of a line, sometimes we're not given the actual equation. Perhaps we have to pull information out of, let's say, a table. And using that table, for this case, degrees Celsius to degrees Fahrenheit, we have a table with information degrees Celsius 0, 25, 50, 75, and 100 with the corresponding degrees Fahrenheit of 32, 77, 122, 167, and 212. Using this data, I can build a graph basically having the Celsius on the x-axis, the Fahrenheit on the y-axis, plot the points, connect the dots, and I have a line. Using this line, I could figure out the equation using one point, using the slope. But we do know that there is a relationship between Celsius and Fahrenheit. And this relationship, if we were going to use our conversion formula, would be F equals 9/5 C plus 32. And indeed, this 9/5 C plus 32, that is the equation of our line that we drew. Visually, that is the equation. So how do we figure out the equation of a line? Generally, we're given some information. At least from the graph point of view, we can figure out the y-intercept and any point. Okay. The y-intercept would be 0, b, and any point is just x and y. Using the definition of the slope, that would be y minus b all over x minus 0 equals our m as in slope. Well, x minus 0 is just x. So what we can do is multiply each side by x, giving us y minus b equals mx. Our goal is to solve for y here, so let's add b to each side. Therefore, y equals mx plus b plus b. That is our equation to our line. Given we had our y-intercept, any point, and using our slope formula. All right, so there's got to be a rule buried in there somewhere. Our property of the slope-intercept form of an equation of a line will be any equation of a line that has a slope of m and the y-intercept of b is going to be given by y equals mx plus b, where m is the slope, b is the y-intercept. That's why it's called slope-intercept form, because without doing any math, just evaluating the equation, I can find the slope very quickly, and I can find the y-intercept very quickly. So let's try an example. Find the intercept of the line with a slope of -4/3 and the y-intercept of 5, and then we'll graph it. Well, the equation is pretty straightforward using this slope-intercept form. Slope m is -4/3, so you're going to put that wherever the m is. The intercept is 5, so you're going to put that where the b is. Therefore, our equation is y equals -4/3 x plus 5. When we graph our line of y equals -4/3 x plus 5, we can utilize what we know about the intercept. We can utilize what we know about the slope. The intercept is at the point 0, 5. The y-intercept is 5, so 0, 5 is 1 point. Using the slope, which is a -4 in the rise and a 3 in the run, I'm going to go down 4 and over to the right 3. There's my next point at 3, 1. And in essence connect the dots. So using the slope, using the intercept, we can graph a line pretty simply. Okay, let's find the slope and the y-intercept for the line that has the equation of 2x minus 3y equals 5. Well, in the format that it's in right now, which is called standard form, it's not easy to find the slope or the intercept. So let's translate the standard form into slope Slope-Intercept form, and that way we can see exactly what's going on here. So 2x minus 3y equals 5. Let's get rid of this 2x on both sides by subtracting 2x, leaving negative 3y equals negative 2x plus 5. I don't want to know what negative 3y's are. Let's divide negative 3 by each term, both on the left, both on the right. Divide by negative 3, divide by negative 3, divide by negative 3. That will give us y equals 2/3 x minus 5/3. Now I can see pretty clearly that my slope is 2/3 and my intercept is negative 5/3, my y-intercept. So let's go back to the definition of our slope, which is y minus y1, x minus x1 equals m. Now that's just a generic point xy, and a generic point that's on the line. Okay. So I want to eventually make this equal, solve for y. So I'm going to multiply each side by x minus x1. X minus x1 on the left, x minus x1 on the right. That will cancel out the x minus x1 on the left, bringing it to the right, giving me y minus y1 equals m times x minus x1. And right now, at this point, this is called point-slope form. Now, pretty obvious, I guess, why it's called point-slope form. Number one, we are given one point, x1, y1, and we're given a slope. And by having it in this format, if the information that I'm given is the slope and 1 point, I can find the equation of the line. Okay, there's got to be a rule in it, right? So here's our property. The equation of the line through x1, y1 with the slope of m is given by the point-slope form of y minus y1 equals m times x minus x1. Now this y, the first y and the first x are just generic x's and y's. They are not necessarily a point. You can put in values for those, but these are generic. The y1, x1, that comes from your point. So let's see how we're going to use this. Find the equation of a line in slope-intercept form for the given point, which is negative 4, 3, and the slope of negative 2. Okay, we are given a point, we are given the slope, so we can put it into our point-slope form, and then from our point-slope form we can solve to get it into the slope-intercept form. All right, let's say our first point, x1, y1, is negative 4, 3, and our slope m is 2. Let's put it into our y minus y1 equals m times x minus x1. Our y1 is a 3, so y minus 3 equals m is negative 2 times x minus negative 4 from the point. Negative 4 is positive 4, so what I need to do now is distribute the negative 2 to the x, the negative 2 to the 4, giving me y minus 3 equals negative 2x plus negative 2 times 4. Negative 2 times 4 is 8. Then I'm going to add 3 to both sides. Remember, I'm just trying to get it to where it says y equals something, and then that would be in the point-slope form. Or, pardon me, in the slope-intercept form. So many forms to deal with. Y equals negative 2x minus 5. And then from there we can graph it. We know the intercept, which is negative 5. We know the slope is negative 2, meaning I'm going to go down to 1 to the right, down to 1 to the right, down to 1 to the right. Or I can switch those directions completely. 1 to the left, up to, 1 to the left, up to, and connect the dots. So what if I'm not given the slope? What if I'm given 2 lines or 2 points, and from those 2 points I need to find the equation? All right, so in this case, find the equation of the line that passes through the points -3, 3, and 3, -1. I do not have the slope. In slope-intercept form, I need the slope. In point slope format, I need the slope. Well, first thing is I have to find the slope. So using m equals y2 minus y1 all over x2 minus x1, I'm going to plug in both of my points. y2 is -1, y1 is 3. x2 is 3, x1 is -3. By plugging that into our slope formula, I can then solve and get -2/3 for my slope. Now that I have slope, and I have one of two points to choose from, I can use point-slope formula to find my equation. So just for argument's sake, I'm going to go ahead and do both points. So the first point that I used was the -3, 3. When I plug that in, y minus 3 equals -2/3 x minus -3. And when I work that through, I'm going to get the equation y equals -2/3 x plus 1. But what if I wanted to use the other point, which is 3, -1? If I use 3, -1, y minus -1 equals -2/3 x minus 3, and I work that through, I get the same equation. Y equals -2/3 x plus 1. Because both of those points are on the line, it doesn't matter which point I use to figure out the equation. But I did have to find the slope first, and then using the slope that I find and one of the points that I'm given, I can find the equation to the line. I mentioned this before, standard form. So what exactly is standard form of the equation of a line? Well, if you're given integers a, b, and c, then the standard form of a line is written as ax plus by equals c. Now this is a good setup when we're trying to put in values for x and solve for y, or put in values of y and solve for x. But it doesn't necessarily tell us immediately what the slope is. It doesn't necessarily tell us exactly what the y-intercept is. If we want to do that, we can solve the standard form for either for slope-intercept form, and then we can find it out really quickly. But technically, a lot of equations come in this standard form. So let's rewrite slope-intercept form into standard form. How would I do that? Well, the first thing is, in standard form, the x's and the y are on the same side. It's on the left-hand side. So I need to end up getting rid of that x. But because it's in a fraction, I'm going to go ahead and eliminate fractions, multiplying everybody by the denominator. That will give me 3y equals -2x plus 3. So add 2x to both sides. 2x plus 3, y equals 3. That is in standard form. Remember, the numbers are integers, not fractions. I could have added 2/3 x, add 2/3 x, but then ultimately I'm still going to have to multiply by 3 because a, b, and c are integers, not fractions, at least for standard form. All right, let's try an example where we want to give the equation of a line going through a point, -1, 4, and also perpendicular to 2x minus y equals 1/3. And then we want to write our equation in standard form. Well, first of all, we're given the equation of a line that is perpendicular to the line that we're looking for. So we need to, number one, find the slope of our perpendicular line. Easy enough. We're going to take the 2x minus y equals 3 and solve for y. Subtract 2x from both sides and divide by -1 for each term, so y will equal 2x plus 3. Therefore, the slope of the perpendicular line is 2. Now, since we're given the slope of the perpendicular line of 2, we need to find the slope of our line. Well, our slope of our perpendicular line is 2, therefore our slope of our line is going to be its reciprocal, its opposite reciprocal. It's positive, therefore it's our slope is going to be negative, and the reciprocal of 2 is 1/2. So our slope to our line we're looking for is negative 1/2. Now we're going to use point slope because we're given our point of negative 1, 4. We now have our slope of negative 1/2. We're going to put it into our point slope formula to be able to solve for our equation. So y minus 4 equals 1/2, our slope, times x minus negative 1. X minus negative 1 is positive 1. Distribute the negative. I have y minus 4 equals negative 1/2 x minus 1/2. Add 4 to each side. Okay. And we're given y equals negative 1/2 x plus 7/2. But remember, standard form does not have fractions, so let's eliminate fractions by multiplying each term by the denominator. So let's multiply everybody by 2. That gives me 2y minus equals negative x plus 7. The last thing I need to do to get it in standard form is to move the x to the left-hand side, add x to both sides. X plus 2y equals 7 is in standard form. Okay, the last little bit I want to chat about in this video are the special equations. And we have 3 special equations here: a line going through the origin, a vertical line, and a horizontal line. The equation of a line going through the origin is going to be y equals mx. In standard form, that would be mx plus negative mx plus y equals 0. But our equation is y equals mx. The slope is m, and because it's going through our origin, it crosses the x-axis at 0, and it crosses the y-axis at 0, so the x-intercept is 0 and the y-intercept is 0. A vertical line is an equation that is x equals a being some number. There is no slope because it is a wall. Our x-intercept is a because it crosses at a. Might be over on the right, might be on the left, but it's just at a. And our y-intercept is none. But, okay, but, I have a little asterisk here. Unless a equals 0. If a equals 0, then our vertical line is sitting on top of the y-axis. And if that's the case, then the y-intercept is the y-axis. Let's look at horizontal line. The equation is y equals b. Our slope is 0. And our x-intercept is none with our asterisk. And our y-intercept is at b. So wherever b is on the y, that's what the y-intercept is. What happens if b is 0? If b is 0, then our line is sitting on top of the x-axis. Therefore, the x-intercept will be the x-axis. Okay? It's just a line sitting on top of a line. Where does it cross x? It crosses x everywhere. Therefore, it is the x-axis line. All right, that's it for this video. Until next time, be seeing you.